my name is Gordon with Glow Research, and we're going to be talking about the March CS-1701 that you can see right here. We're going to explain the operational procedures, but before we get into that, I'd like to tell you just a little bit about the history of the March CS-1701. The system was designed by Randy Crockett, who is now the president and owner of Trion Technology. The system is designed to have a bottom-powered electrode. It has water cooling, so you can keep your sample cool. It has a RF generator that is a 600-watt AE generator. The system typically comes with at least 2 mass flow controllers. This one has 2 mass flow controllers. And we're going to go through and show you how the system operates, and hopefully that will be of some help to you. And now I'd like to introduce Odin Hefta. Odin has got about 30 years of plasma experience in repair and plasma engineering, and he will go through the operation of the March 1701.
Hi, I'm Odin Hefta. I'm going to show you how to operate the CS-1701, or at least part of it. What you'll see now is we've pumped it down to a base pressure, just to kind of show you that the system's tight. We're at 17 millitorr. What I'll do is go ahead and vent it back up, and we'll open the chamber. Right now we are vented, so the chamber simply lifts up and you can set your sample inside. Chamber has been professionally cleaned, as well as all new O-rings, so vacuum integrity is very good. Again, like Gordon had mentioned, we got a RFX 600 generator. When mated to the 1701, you'll notice that we have the remote control and the signal remote, or the remote signal, need to be on, so the 1701 has control of the RF enable as well as the power level. Quite simply, we got a power on and off of the 1701. This is your matching network. We're in auto tune. You'd use manual if for some reason you wanted to manually tune it if you couldn't tune. On our screen here we have programs 1 through 9, so you can make changes to any one of these programs as needed. For setting a program, we turn the set on and we can go through the different displays. Right here we got power. We have it set at 200. We can increase or decrease. Our time, we have 30 seconds in there. Again, we could increase or decrease as needed. Auxiliary, this is our crossover to where it'll pump down before it crosses over and turns our gases on. Same thing over here on the MSCs. We can do set, and this system has 2 MSCs in it currently.
How many you can have up to? 4?
Up to 4 MSCs.
4 MSCs. Okay.
It can be fitted. Everything's in there. It would just be physically adding 2 more MSCs. So, and again, here we're in the set point. We can increase or decrease as needed. You also have manual operation, where you could manually turn on the vacuum, connect to your Baratron, turn your gases on, RF on, vent, or in auto. We'll run in auto. So you can see we have program 1. We're in auto mode, and we simply hit start, and it will pump down the chamber. After a delay, it'll turn on the flipper valve, which allows the Baratron to look at the chamber pressure, and it'll probably be below 80 millitorr, so we won't see that crossover. That's why we're not, okay, there our pressure turned on. You see our vacuum starting to drop here, pressure's dropping. And at 80 it'll say, hey, I'm okay, I can turn on gases. There's probably a slight delay in that also. There, now our gases came on. We'll switch over. We had a set point of 30, and we're at 30% flow. You see it gives us right around 460 some millitorr. Now there's also delay a gas stabilization delay before the RF will turn on. So we probably got 15-20 seconds left before RF will come on. And then our timer will start counting down from the 30 seconds. There we got RF on. See, the generator's 200 watts. Our system's reading 202. Obviously, remember we have a 200 set point. And now you can see our timer, our 30 seconds is counting down. And when it's expired, obviously the RF will turn off and the chamber will vent back to atmosphere. There will be a evacuation time that'll pump the chamber down before we vent. So now our vents come on. And within a few seconds we can open the chamber back up. Now we're back at atmosphere. You can remove your sample.
Oh, Dean, what type of samples are typically run? Oxide etching, nitride etching?
Yeah, the narrow gap is probably better for oxide etching. It's an RIE system, so.
So you have a powered bottom electrode, and there's a DC bias on the bottom electrode.
Yeah,
there's no way of monitoring the DC bias, but there is a bias.
Yeah, there is a bias. The 1701 doesn't display the bias, but there will be a DC bias potential on it. So
other applications would be like polyimide etching. You could do photoresist stripping in here as well.
Yep.
Okay. And obviously cleaning, different sorts of oxygen cleans, things like of that nature.
Right. Yeah. If
but
you had
mostly,
O2.
It's designed for CF4 SF6 type applications.
Yes.
Okay, very good. And let me do one more.